Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. So thank you for being here today. Today I will share a simple but important finding about operational fuel intensity at sea. The main message is this: when we compare fuel intensity across different weather categories, fuel type explains the difference much more strongly than the weather does. So let me briefly frame what you are seeing on this title slide. We are looking at operational records, meaning real world operation, not laboratory tests. In practice, people often use fuel consumption by blaming the weather first, rough at sea, strong wind, current, swell, and then we assume fuel goes up. That is true in many cases, but the question is how strong is the effect compared with something we can control more directly, which is fuel type. So my name is Amir bin Kamis, and I'm from Universiti Malaysia Terengganu. On this slide, I want to make the study design very clear because the result is only meaningful if we trust the logic of the test. First, the research question. In operational record where weather is recorded as broad categories, does fuel type explain fuel intensity more strongly than weather? And secondly, is the fuel type effect stable across weather states? In other words, does diesel stay lower than heavy fuel in calm condition, moderate condition, and stormy condition without changing its advantage? Now, the study design, this is an observation data set. We did not manipulate the vessel or force routes. We use operational records. Fuel intensity here is defined as fuel consumption per unit distance travel. This is useful because it linked to transport work, not just fuel per hour. The data set includes 1,440 operational observation from 120 ships. We test two fuel types, diesel and heavy fuel. We also classify weather into three classes, calm, moderate, and stormy. For analysis, the main tool is two-way ANOVA, and this allows us to test three things. One, the main effect of fuel type. Two, the main effect of weather category. Three, the interaction effect between fuel type and weather category. The interaction is important because it tells us whether the advantage of one fuel type changes when the weather changes. So the logic is straightforward. If the fuel type is strong, we should see a large and significant fuel type effect. If weather category is strong, we should see a large and significant weather effect. If the fuel type advantage changes across weather, we should see the significant interaction. Now, I will show the first key result, which is simply the main difference between diesel and heavy fuel in fuel intensity. We move on to the core finding. So this slide shows the average fuel intensity by fuel type across the data set. The chart make it easy to see the separation. Diesel has a low mean fuel intensity and heavy fuel oil has a higher mean fuel intensity. The mean value are approximately 26.48 for diesel and about 32.30 for heavy fuel. That means heavy fuel oil is higher around 5.85 unit. So if we express that relative to the heavy fuel oil mean, it's about 18% higher. So the first key message here is not complicated. In this data set, fuel type is associated with a clear difference in operational fuel intensity. Now, let us interpret this carefully. We are not claiming that fuel chemistry alone causes everything. Operational fuel intensity is influenced by many things, such as vessel design, loading, speed, maintenance condition, and route profile. But when we average across many observations and ships and compare these two fuel types, the separation remains consistent and large enough to matter. From an operational perspective, this is important because fuel selection is a level that management can control. If fuel type differences are large, then policy, fuel switching strategy, and fuel planning can deliver meaningful improvement in fuel intensity. So at this stage, someone may ask, what about weather? Surely, stormy weather increase resistance and that should increase fuel intensity. Yes, but the question is about magnitude and about whether broad weather category and more explanatory power than fuel type. That's why the next slide is important. It shows fuel intensity split by both factor, fuel type and weather category. So we can see whether the fuel type separation persists in calm, moderate, and stormy condition. So this slide answer a practical question that many seafaring operators will immediately ask. Does the diesel versus heavy fuel difference appear when we break the data into calm, moderate, and stormy weather? Look at the group bars for each weather class. You see two bars. Diesel is consistently lower and heavy fuel is consistently higher. The separation is visible in calm, moderate, and stormy condition. What is also interesting is the weather trend. When weather changes from calm to stormy, the average fuel intensity does not jump dramatically in this dataset. The value drifts slightly, but the dominant pattern remains the fuel type separation. The table on the right supports the visual message. Within each weather class, diesel remain lower than heavy fuel oil. And the slight note that all three comparisons are statistically significant. That means the difference is not just visual noise. So what is the take-home message from this slide? It is that the fuel type signal is stable across weather state. Even when weather condition changes, diesel remain lower than heavy fuel by fairly consistent margin. So this matter operationally because it suggests that fuel planning decision can deliver consistent benefit rather than benefit only in specific weather. It is also suggests that if we use broad weather categories, weather may not capture enough detail to explain fuel intensity changes. Real weather effect may require more granular measure, such as wind speed, wave height, relative direction, rather than simple calm, moderate, stormy weather. Now, the strongest evidence comes from the formal statistical test. uh, Alright, this slide is the statistical confirmation of what we have observed visually. First, the fuel type effect. The ANOVA shows a very large F value for the fuel type and extremely small P value. This tells us that fuel type explains a meaningful share of variance in fuel intensity in this dataset. The effect size shows a partial ETA squared. It's about 0.079, which is clearly larger than the other factors on this slide. Second, the weather category effect. Weather has a small F value and non-significant P value. The effect is around 0.002, which means that using broad weather categories, calm, moderate, stormy adds little explanatory power for fuel intensity in the dataset. Third, and very important, the interaction between fuel type and weather. The interaction is not significant and the effect size is also about 0.02. This is the statistical statement that the fuel type advantage is stable across weather changes. Weather category. In plain language, diesel stay lower than heavy fuel oil in calm condition, moderate condition, and stormy condition. The gap does not meaningfully change. The small bar chart on the lower left reinforce the same idea by comparing relative signal strength. Fuel type is the dominant factor, while weather category and the interaction contribute very little in this model. Now, let me explain what this means operationally. It does not mean weather is relevant. See, weather clearly affects safety, routing, speed decision, and ship handling. But in this data set, and with this weather classification, fuel choice is a more robust separator of fuel intensity. So the operational focus suggested here is to prioritize fuel selection and fuel switching policy as main lever. Weather-related action remain useful, but more as a secondary level, such as routing choices and speed management, especially when the weather classification is cost. Right, so let me conclude with the bottom line and practical meaning. The bottom line is that fuel type has a strong and statistically significant influence on operational fuel intensity. Weather category were recorded as calm, moderate, stormy, shows a small and not significant main effect in this dataset. And importantly, there is no fuel type and weather interaction, meaning the separation between diesel and heavy fuel oil remains stable across system. So what should an operator do with this information? If the goal is near-term operational efficiency and decarbonization action, The priority should be fuel type selection and fuel switching policies where possible within compliance and availability constraint. That can be more reliable rather than relying on both weather category. At the same time, weather should be treated seriously for voice planning, safety and performance management, but in terms of planning variation in fuel intensity in this particular data set, weather categories are not the dominant driver. They suggested that if we want weather to explain more, future work should measure in more detailed ways, such as wind speed, direction related to the cost, wave height, and current component, not just in three level, level deep level. I will end with a simple message. Field type navigation can provide consistent performance benefit across calm, moderate, and stormy conditions. Weather still matters at sea, but to quantify its fuel effectively, we may need final weather inputs and then broader. All right, so thank you for